And thanks everyone at AI Tech North and all my joint presenters today. It's really great to be along at this this webinar today. So like Sharon says, my name's Heather Dawe. I'm UK Head of Data at UST-Global. We're based at, well, we've got a Leeds office, but that's where my team works out of. So I'm here today to talk about AI explainability and bias in machine learning. And I think this pretty nicely augments from Jamie's and Sunil's talk. It's not, you could, I mean, in some ways you could take it as a negative slant on AI, but I certainly don't mean it to. It's just how we work to avoid some of the issues that we've seen in applying AI in everyday life just recently. So I'm just going to, hopefully my slides are changing okay. So two different, and this is my first slide. I just want to talk about the technical cause of both of these two problems. The first, one of which I think many of us will be familiar with. August time this year, when exam results came out, and the U-turn that had to take place when the government moved away, the UK government, well, the Scottish and the English governments, in fact, they both moved away from reassessing students' grades using an algorithm technique, and instead went back to using the teacher estimates solely. And then again, this just happened on Sunday, this Sunday, this Guardian article. So Twitter apologising for what was perceived as a racist image cropping algorithm when users used Twitter and Twitter seemed to focus white faces over black faces in the algorithm. So they pulled it. Now, what's the technical cause of both of these problems? Two very different problems, and two, that led to significant issues. The technical cause is data bias. And I'm going to talk about bias today and its impact on machine learning models, and therefore applied when machine learning models are applied as artificial intelligence. So what is bias in data? I think it's important to reflect on the fact that, sadly, we actually do live in a prejudiced societies, whether we like it or not. And the data we build our machine learning models on reflects society. So, it's very likely to carry bias. And sort of looking, there are different classifications of bias. You've got sample bias, when the data machine learning models are trained on do not accurately represent the population of focus. So, for example, the Twitter issue was likely caused by the fact that the algorithm wasn't trained sufficiently on an ethnically diverse training data set. You've got prejudice bias. I was thinking about some of this. So when the training data precipitates stereotypes. So I've got two children, two girls, and when I had my first baby, I got a load. We all got a load of pink cards, which was brilliant, very kind of my friends and family who sent them. But if a machine went to a card booth and sort of looked at the baby cards, the data, the sort of stereotype it pick up that girls like pink and boys like blue. That's prejudice bias. Exclusion bias is excluding data when you don't think is relevant when it actually is, and that's I was trying to think about an example of this. That's when an outcome is inherently linked to something you wouldn't imagine it's linked to. And then we have experimental bias when the data scientist or other analyst or whosoever is building a machine learning model has conscious or unconscious bias, and that carried through into their machine learning model. And then you have measurement bias, and this could be a faulty ruler, or it could be faulty any kind of measurement. A faulty ruler that measures, that's just slightly askew in terms of the centimeters it's measuring. Any instrument or collection entity that collects that data has bias. So there's all these different kinds of bias, and it's in our data, and the data is used to train models. And the outcomes we see, or we have seen, are things like the algorithm issue with exam results this summer, and Twitter having to pull their photograph filter at the weekend. So why does bias matter? And so I've given two examples today about adverse outcomes. Twitter didn't want it to happen, and I actually want to. The main impact of the exam results for Rory this summer with the students, of course, that it impacted on. So, you know, there was a U-turn, and understandably so. So, you know, there's two examples of adverse outcomes caused by bias in machine learning models. I should say the exam results were shown to unfairly unfairly lower grades for students in deprived areas, for example, and other things too. It was shown to be biased. You know, no one ever actually got to see that algorithm externally, that the algorithm or algorithms that you use, but it was shown that there was bias in the algorithm. So there's two examples, you know, that we've seen in the news and you see them quite often. You know, Facebook has, you know, Amazon, when they use face recognition and other technologies, that there is still an ongoing challenge with them in the fact that there is bias in the models that in the AI they're using, and they're not alone in this. They're just more commonly seen because they're the bigger players. So, you know, there is inherent bias in the data we use to train the models. I mean, you know, we see this stuff in our data in the news and such like. I mean, one of my questions is what, you know, AI is deployed now all over the world in many different places. So what about AI that is actually biased but has not yet been recognized as such? That's going to be around us now. And I'm not trying to scare people. I think it's a recognized issue. So what's the risk? You know, the impact of AI failures. You know, machines get perceived as racist, sexist, and other things. I mean, you know, potentially significant. You know, if it's in machinery, the automated machinery, failures can happen that could be dangerous. And you know, it's perhaps not such a bad thing if you know, the pace of these kind of issues slow down the impact. Well, certainly the pace of utilizing AI, because whilst I'm an advocate for AI and I do believe it, you know, as Jamie and Sunil and Sharon have been saying themselves, like, I'm an evangelist. It's just, you know, if we go too fast, we may, you know, we see issues that we could avoid if we take some more consideration with them. So you know, so there's potential slowdown in utilizing AI. Not such a bad thing, but you know, it's all part of the sort of progression into more use of AI across industry and in our world. So I've got a paper here that was published by the Information Commissioner's Office in May this year, so explaining decisions made with AI. This is an example of the fact that regulators across the world they're completely aware of the fact that more control needs to be exerted over AI and its deployment. And you know, particularly this year, the development of regulation has upped its pace considerably. The Information Commissioner's Office consulted earlier this year, where we responded to that, and many others did, I'm sure. But the regulation and guides are being formed. They're not yet there completely there yet, but responsibility is largely being placed for ensuring that there's no sort of adverse outcomes going to happen from deploying AI. The responsibility is being placed generally on the business deploying the AI. So if you're developing a product that's going to, in healthcare, you can understand the significant need to regulate that industry, because if you're making clinical decisions are being helped by a piece of AI, you need to ensure it's not biased and it's not in a negative way that's going to impact on patients' health, you know, or the other similar things. So, and you know, the recommendations that are typically coming out is that AI explainability needs to be built into the deployment process, whatever that is. So where is AI explainability needed? We've been discussing today all the different industries where AI is now being used. So, I mean, I'd suggest they probably it's needed in all of those industries, and you know, industries where the use of AI is currently emerging. We're at UST, we're liaising with clients in diverse areas such as asset managers, and what we're finding is with ethical and social governance requirements that are now in place, known as ESG, there's a need when asset managers are using machine learning to help, you know, to either make their business decisions or help them to make their business decisions. An assurance that the machine learning models that do not carry bias in any way in this space is required. Likewise, there's a positive, very positive slant here in the fact that if you can show a sort of positive bias for an ethical and social area, then that can become more an ethical fund. Well, that can be shown to be an ethical fund, and one that's suitable. Well, to enable, sort of facilitates the decision making when it comes to investing ethically. Healthcare, I've already alluded to decision support applications. That the key sort of any machine learning models that assist use with AI to assist the decision support process needs to ensure that they're not biased in any way for different patients or different patient journeys. And then in retail, I mean, we're all familiar with being recommended different products and such like it as we do our online shopping. It's not a good outcome for retail if you're recommended something that is either, well, if you don't want it, you'll just sort of won't pay much attention to the recommendation, but it could be more negative like that. The offering could be something that is construed as a prejudice, and that's obviously something you don't want. So we're increasingly having conversations with our clients in this space as they start to use machine learning more within their business processes. They recognise in the need to assure themselves that their machine learning models are not biased. So that's where it's needed. So I'm saying all this, and this is quite, AI explainability is quite it's definitely a thing, and it's also really quite complex in the fact that it's not just about understanding machine learning. It's understanding the nuances in a machine learning model that could impact on whether that machine learning model could be perceived to be prejudiced in some way. I mean, the past five years or so or more, frameworks and such like have been developed that help to explain AI and to ensure that machine learning models do not, well, at least if they carry bias, you can measure it. I think we think these methods and these tools are still, and it's importantly, I should say as well, explainability toolkits are available on Azure, AWS, and the Google Cloud. So, the big players in this space have offerings in the explainability space to help businesses and others to explain the machine learning they're using and therefore ensure it's not biased. However, there's still, it's still really quite limited by its complexity. And what I mean here is, I can use this stuff. I've been working as a data scientist for years. I think we need to make explainable tools more accessible to non-data scientists, to business experts who have a deep domain knowledge of their space, but not necessarily any knowledge of Shapley values or some of the other metrics and statistics that can be used to explain bias in AI. So we've, at UST, we've developed with the sort of aim of making explainability more accessible to people other than data scientists, non-data scientists, perhaps the sort of concept of a sit-in data scientist or, business expert. And we've developed a product we call Starfare that we're now working with our clients to embed it into their business processes, their analytics processes. So, for example, the screen here is showing, it takes machine learning model and the associated data, you just construct it, and it feeds back a dashboard to the non-data scientists to show. And the example here shows that the model has potential bias for age, it has potential bias for race, and the model, being analysed by Starfare has strong reliance on the race feature. So there's a real risk there that we could see something that's similar to happening to what happened to Twitter at the weekend. There was the model favoured white faces as opposed to black faces. So, and we're increasingly developing this product and working with our clients to learn from it, because we see that this is a burgeoning area that needs to be built into any sort of any AI that is developed across industry. And we're also seeking to increase awareness of this need, because, I come back to my first two slides, which wasn't meant to be a negative thing about AI, but it's these new news items that do make AI perceived to be a negative thing. I'm an evangelist for it, and I think it's important, though, that we're aware of the impact of bias in AI, and how we can, the impact of of bias in AI, and that it actually can be monitored for and removed to ensure that we don't have these adverse outcomes. Well, we reduce and avoid these adverse outcomes going forward. So that's pretty much all I wanted to say about explainability today. Thanks very much for your time. And what I should have done was I should have put a slide in about to both say my email, but also, if you've got any queries or any questions, obviously put them in the chat, please. If you'd like to discuss further, please do get in touch. Likewise, on the 6th of October, in conjunction with our friends at AI Tech North, we're organising a hackathon that's based upon an enriched COVID-19 data set that we've developed. So it's an open invite, really, for you to attend. We'll put a link in the chat later. There's still some places, so please do come along. But yeah, thanks very much. I think that's everything from me.